So hello students, let's in this video we will continue with the CBSE questions asked from the topic Pythagoras Theorem. Well, it seems as if CBSE is very much inclined towards this topic, as many questions are asked from this topic every year in the board exams. So let's take the sixth example. In a triangle ABC, AD is the median, and we have to prove this result. So, how to begin? Well, we have AB square, AC square. So, from seeing this equation, we get an idea that we can use Pythagoras theorem in this. So, and to use the Pythagoras theorem, we should have right angle triangle. So we will make a construction in the diagram. We will draw AL perpendicular to BC, and then we will apply Pythagoras theorem. Now we have three triangles in which we can apply Pythagoras theorem. So let's take the first triangle, triangle ALB, triangle ALB. In which we have AB square is equal to BL square plus AL square. Then again we have triangle ALD in which we can apply Pythagoras theorem. We have AD square is equal to DL square plus AL square. And then we have a triangle ACL in which AC square is equal to CL square plus AL square. So let this be equation 1, equation 2 and equation 3. Adding equation 1 and 2. Why we are adding 1 and 2? Because here we have AB square and here we have AC square. If we add these two, we will get the LHS of our final expression. So let's add equation 1 and 2. So we have AB square plus AC square is equal to BL square plus AL square plus CL square plus AL square. So in our final expression, we don't have AL in the picture, so we will eliminate AL. We'll leave LHS as it is because we have got the LHS same as our final expression. So continuing with BL square, we will substitute AL square from equation number 3. Substituting AL square as 2 into AL. What is the value of AL? It's AD square minus DL square. Then we are left with CL square. Okay. Now BL. So AD we have in our final expression. We have BD. So let's try to include BD. So how we can do that? BL. This whole length is BL. So BL is equal to, we can write BL is equal to BD plus DL. Okay. Why we are writing BL is equal to BD plus DL? We could have written BL is equal to BC minus LC. But we won't do this. Why? Because we want BD in our final expression. So we will make this substitution. So let's substitute the value of BL. We have BD plus DL whole square. plus 2AD square minus 2DL square plus CL. Again, we don't have CL in our final expression, so we will eliminate CL. So how we can write CL? CL is equal to CD minus DL, and CD is equal to BD. CD is equal to BD. Why? It's given that D is median, midpoint. So D is the midpoint. So that's why CD is equal to BD. So we will write CL is equal to BD minus DL. So let's make the substitution for CL. So we have BD minus DL whole square. So let's open everything. We have BD square plus DL square minus 2BD into DL. Then again plus 2AD square minus 2DL square. Then opening this, we'll have plus BD square plus DL square, then minus 2BD into DL. So minus, oh, there should be plus, it's plus, so it should be plus. So this got cancelled. And what else will be cancelled? This, we have DL square, DL square. Okay, we have 2DL square and we have 1 minus DL square, 2 minus DL square. So this and this will get cancelled. So what we are left with? We are left with BD. So it's 2BD, BD square plus 2AD square, which is equal to, taking 2 common, we have AD square, this is AD square plus BD square. Hence, we have proved our final result. Welcome student. Let's take the 7th example on Pythagoras theorem. In this question, BL and CM are the medians. So this is BL and this is CM. These are the medians of a triangle ABC, which is right angled at A, and we have to prove this. So again, as squares are involved, so we will apply Pythagoras theorem. Also, this angle is 90 degree, so obviously we can apply Pythagoras theorem. So we have 3 triangles in which we can apply Pythagoras theorem. So let's see what are those triangles. First, this triangle BLA. Then we have a triangle ACM, and obviously the bigger triangle ABC. So let's write the equation for all the 3. So in triangle, okay, we'll take the red one, triangle ABL. We have BL square is equal to AB square plus AL square. Okay, then in triangle, this blue triangle AMC, we have CM square is equal to AM square plus AC square. And in the bigger triangle ABC, we have BC square is equal to AB square plus AC square. So BC square we have in our final equation. So, and we don't have AB and AC. So we'll continue with this. Let this be 1, this be 2, and this be third. So we have BC square is equal to, let's substitute the value of AB square and AC square from 1 and 2. This is AB square and this is AC square. So we'll put the values. We have BL square minus AL square plus AC square, we'll write it as CM square minus AM square. Okay. So again, BC square is equal to BL and CM we want in our final expression. We don't want AL and AM. So let's try to substitute these. So we'll write BL square minus AL square. What is AL? AL. This is AL. So AL we can write it as AC by 2 whole square, because L is the midpoint. So we can write AL as AC by 2. So we'll substitute AL as AC square by 4. We'll square this, so it will become AC square by 4, AL square. Similarly, we have CM square minus AM. AM will write as AB upon 2. So let's substitute the value of AM square. We have AB square by 4. So again, solving this, we have BL square plus CM square, this, taking minus common, and 1 by 4 common. We have AC square plus AB square. And again, AC square and AB square is equal to BC square from equation number 3. AB square plus AC square is equal to BC square. So we will substitute here BC. So again, we have BL square plus CM square minus BC square by 4. Now taking BC to the LHS, we have BC square plus BC square upon 4 is equal to BL square plus CM square, which is equal to, we'll take 4 as LCM, and here we will have 5 BC square is equal to BL square plus CM square, or we'll take 4 this side. We will have 5 BC square is equal to 4 times BL square plus CM square. So we have proved our final result. Hence, proved.